Today we're going to talk about unit conversions. It's also known as dimensional analysis. You may have talked about this a little bit in some of your science classes. The first thing I want you to think about are conversion factors, what they are, where you've seen them, and maybe you know what they are, but you don't know that you know what they are. An example of a conversion factor might be that in one day there are 24 hours. So this is an example of a conversion factor. Notice that both of these are equal to one another, meaning that if I say I spent an entire day doing something, then that's the same thing as me saying I spent 24 hours doing something. They're the same amount of time. It's an equivalent fraction. So what is a conversion factor? Conversion factors are ratios written in fraction form, so here's my fraction, that can express the same value or quantity in two different units. So I've expressed the same quantity, the same amount of time, but in two different units. The numerator is in days and the denominator is in hours. So an example of when or why you might need to use conversions. Well, in my personal life, I vacationed in Italy at one point, and I was using the treadmill, and it was in the metric. It was using the metric system, and so I was used to running so many miles, and I needed to know how that converted into meters or kilometers, actually. So that would be an example of when I personally used it. Anytime really that you're traveling outside of the U.S., everyone except for the U.S. is on the metric system, and so being able to convert between English system and the metric system is something that you would want to know how to do. Runners do this all the time when you're thinking about running a marathon. How many meters, how many kilometers is that? So there are lots of times you might need to use conversions. So let's look at some examples of how we would use these unit conversions. The first example, let me move this out of the way. The first example is Bob studied for 2.5 hours. How many minutes did he study for? Now this is something that I want to point out, but I don't want you to get used to this wording. I really want you to just sort of understand why you're putting the units where you're putting them. But in this case, which is the most basic example, you can definitely use this to help you. So if Bob studied for 2.5 hours, and I want to convert that into minutes because I want to know how many minutes he studied. Well, I can go straight from hours to minutes because I know how many minutes are in an hour. So in 2.5 hours, I can multiply by my ratio what I want on top, what I have on the bottom. So I want my answer in minutes. I have hours. So what is a ratio that I can set up that's an equivalent ratio that compares minutes and hours? Well, in 1 hour, there are 60 minutes. That's an equivalent fraction. My numerator and my denominator are the same value, but just expressed in different units. So I'm going to go ahead and talk about why we don't want to necessarily get into the habit of using the what you want over the what you have. In this case, I'm done and I can multiply and my units cancel. But in other cases, you're going to have a long string of these ratios that are multiplied together, and trying to use this might get a little confusing. So anyways, the reason why we put what we have on the bottom of my ratio that I'm multiplying by is because then my units cancel out, and the only units I have left in my problem is minutes, and that's what I want my answer to be in. So I've got 2.5 times 60 in my numerator, and I end up with 150 minutes. So if Bob said that he studied for 2.5 hours, he could also say he studied for 150 minutes. Either way, he's talking about the same amount of time. Let's try another example. It asks us how many seconds are in 1.4 days. Well, in this case, I'm not going to be able to go straight from seconds to days. I personally don't know off the top of my head how many seconds there are in a day. If you do, that's awesome. You can go straight there, but I don't. So I'm going to use this conversion plan. I'm going to go from days to hours because I know how many hours are in a day. Then I'm going to go from hours to minutes because I know how many minutes are in an hour. And then I'm going to go from minutes to seconds because I know how many seconds are in a minute. So let's set up our ratios. I've got 1.4 days, and I'm going to start multiplying by my ratios. And remember, my numerator and my denominator are going to be the same value. So I want to be able to cancel out my units of days, so I'm going to put that one on the bottom. And I'm going to go from days to hours because I know that there are 24 hours in one day. Again, I'm trying to get to seconds. So next I'm going to put hours on the bottom. Let me go back and cancel my days. Put hours on the bottom so that my hours cancel, and I know how many minutes there are in an hour. 60 minutes in 1 hour. And then lastly, I'm going to go from minutes to seconds, which is my final unit that I'm looking for. In 1 minute, there are 60 seconds. So I can cancel out my minutes. Notice the only unit I have left is seconds, which is what I wanted. And I'm going to multiply all of my numerators together, and I get 120,960 seconds. And I could put that over 1. Notice all my denominators have a value of 1, or I can just leave it as it is. So again, if I say I went camping for 1.4 days, I could also express that and say I went camping for 120,960 seconds, and I'm talking about the same amount of time. The third example is a learning check. So I want you to pause the video, and I want you to try this example on your own. After you've tried this on your own, I'm going to go ahead and go through the example and see how you did. Alright, if a ski pole is 3 feet in length, how long is the ski pole in millimeters? Now, sometimes people can get to where they want to go in taking different paths. I happen to know off the top of my head, how many centimeters are an inch, so I'm going to go kind of that route. If you know a different conversion to use, that's fine too. But I know that I'm going to go from feet to inches because I know that there are 12 inches in a foot. That gets rid of my feet. Then I'm going to go from inches to centimeters because I know that there are 2.54 centimeters in every inch. That gets rid of my inches. And then I'm going to go from centimeters to millimeters because I know that millimeters. I know that there are 10 millimeters in every centimeter. Again, I'm going to multiply my numerators together, and I get 914.4 millimeters. And again, if I multiply my denominators together, I'd get 1. So if a ski pole is 3 feet long, I could also express that and say it's 914.4 millimeters long, and that's the same length. The next couple of examples are a little bit more complicated because now we have 2 units to convert. So we have John Eisner serving 140 miles per hour. So now notice I've got a denominator of 1 hour, whereas all the examples we did before didn't have a denominator, a unit, I should say, in the denominator. So I'm going to go miles per hour into feet per second. So I'm going to choose to convert my distance first. So I'm going to go from miles straight to feet because I know how many feet are in a mile. There are 5,280 feet in a mile. That gets rid of my units for miles. Now I'm in feet, which is what I wanted, but now I have to go into seconds. So I'm in an hour, and I need to go from hours to seconds. Now I need to put hours on top so that my hours cancels down here. So I've got 1 hour, hours into minutes. There are 60 minutes in an hour. And then I want to do minutes on top to cancel out here and put seconds on the bottom. So I've got 60 seconds in 1 minute. Multiplying the numerators together and the denominators together, I've got 140 times 5,280 on the top. That gives me 739,200 feet. And multiplying on the bottom, I've got 60 times 60, or 3,600 seconds on the bottom. I'm going to go ahead and simplify that, and I get 205.3, and that's repeating, feet per second. So when I say that this tennis player serves 140 miles per hour, I can figure out that that's 205.3 feet per second. The speed limit on I-75 is 65 miles per hour. How fast is that in meters per second? So I've got 65 miles per hour, and I want to turn that into meters per second. So I need to take my miles, and I'm going to go from miles to kilometers. And I know that there are 1.6 kilometers in every mile. And then I'm going to go from kilometers to meters. And I know that there are 1,000 meters in every kilometer. So now I'm where I want to go, cancel those miles. I'm where I want to go as far as my distance. So I've got meters, but now I need to go into seconds. So I'm in hours, and I'm going to convert hours into minutes. I know that in 1 hour there are 60 minutes. And then I'm going to convert from minutes into seconds. In 1 minute there are 60 seconds. So now my units left on the top are meters. My units left on the bottom are seconds. And that's what I wanted, meters per second. When I multiply numerators together, I get 104,000 meters over 3,600 seconds. Now I'm going to reduce. Once I reduce, this becomes 28.9 meters per second. Our last example. I decided that I need to lose weight, and I created a diet plan and an exercise regimen that would help me to lose 6 pounds per month. How many ounces did I lose per day? So I've got to figure out, if I'm going to lose 6 pounds per month, how many ounces is that per day? So I've got 6 pounds per 1 month. And I'm going to turn that into ounces per day. Well, I know how to go straight from pounds to ounces. There are 16 ounces in 1 pound. And then I'm going to go from months to days. Now again, here you could put 28, 29 if you're talking about February, leap year, not leap year, or you can do 30 or 31. I would say on average it's 30, so I'm going to go ahead and put 30 days in a month. So now I'm left with ounces per month. Multiplying the numerators together, I get 96 ounces over 30 days. Simplify that, that becomes 3.2 ounces per day. So if I'm going to lose 6 pounds per month, that's the same or equivalent to losing 3.2 ounces per day.